This conference will now be recorded.
Alright, so in today's session, basically we are going to understand about two things. The first thing is security of web services URLs, because the main purpose of IIB is for securing the web services URL. The second thing is applying bar override. I will tell you what is this applying bar override. So if you're already aware, that is fine, but I will give you an explanation about it. So first of all, let me give you an explanation about the security. I mean, what is the intention of security in IIB? Okay. So the thing is, the basic agenda of IIB is, with the help of IIB, we can build. I mean, the developers can build web service URLs with the integration toolkit. So in the previous session, I mean, in the day before yesterday session, we have already seen about the integration toolkits, and we developed a sample message flow. In the same way, they can build the web services URL also. Now, for example, let's assume there is a URL called google.com. So consider this google.com is developed by say with the IIB protocol, with the IIB stuff. So whenever an URL is there, that URL could be a secured one or it could be a non-secured one, right?
Yes.
So the thing is, for example, okay, so let me, instead of google.com, let me open gmail.com. So let's log in. No, don't log in. Sign up among the accounts. Let's see. Okay. So when I open google.com, see, it is asking for the username and the password. So the person who knows this username and the password, they can log into this Gmail account, right?
Yes.
So the thing is, if you see here, it is a HTTPS protocol. It means whatever the password we are going to enter, that is going to travel through network, and that is going to hit the Google server, and in the Google database, that is going to verify the password which has been supplied, that is correct or not. And if it is correct, then it is going to throw, it is going to open the Gmail inbox and all. If it is not correct, then it is correctly say that the password is not correct. It means in the back end, this password is going to travel in the network, right? So whenever the password is traveling, it could be it can be transported through an encrypted way, or it can be transported through a non-encrypted way. Encrypted means it's a secured one. Non-encrypted means it's not a secured one. It means anyone can hack it. Anyone can steal your password via network by hacking your stuff. So right now the thing is, we can clearly see it is not just a HTTP, it is a HTTPS. It means it's a secured one. This URL itself is secure one. It means whatever the data we are going to enter in this URL at the back end, that is going to hit the server in the network in a encryption mode. Do you know what is an encryption?
Yeah, it is a form of
Right. So
hiding the data, masking the data.
exactly, it is going to mask the data so that the hacker maybe get confused, or the hacker may not hack it. That is what encryption is. Right now, the thing is, consider the developer developed an HTTPS URL. Now, whenever HTTPS URL is developed, it is not only putting a security in the URL level, in the broker level also, where this URL has been invoked, where the message flow has to be transformed. There we have to we have to invoke the associated security certificates of this URL. Then only the broker, whenever the message flow is processing a message in this broker, for this URL, that will become a secured one. Okay. So for example, let me show you something. Now you got some clarity why we need to secure website URLs.
Yes.
All right. Now let me show you something here. So in our machine, we already have a broker. Consider this broker is running. Now our intention is, so whatever the URL, whatever the web service is called that is deployed in this broker, that has to be secured one. That is what our intention. So the thing is, in the IIB 9, the greatest advantage, so the work is very minimal, very simple, very easy. But if you see in MB6 or MB7, really there have to be a hell lot of stuff we have to do. So that has been completely minimized from IIB. So that's the greatest thing. So in the making a doing a security, doing an implementation of SSL is a very simple task from IIB version. So in this version, what we are going to do is, okay, where is it? Okay. So there will be something called some trust store will be there. You know, a trust store is something that will trust and then that will store that particular certificates. So if we go to this part, our installation path, CD, OPT, IBM, PinQSI 9, there will be something called JRE 70. Here it is. Go to JRE 17. In this part, there will be something called library, LIB. In library, again, there will be something called security. Where is it? Here it is.
Right there.
Go to this directory. Yeah. Now we are in our IIB installation path, JRE 17, library, security. In the security, we will be having a file called CASUX. So this CASUX is going to act as a trust store and then a key store. So trust store is something that is going to store certificates, and key store is something that is going to store your certificates. Till IIB, both are different tasks. From IIB, from IIB 9 onwards, IBM to combine them with a CSX. It is going to act as your trust store and then your key store.
So is CA service and the key store different or same thing?
It's the same thing. CSX does two things. It is going to trust your certificates and it is going to store your certificates. It will do both the things. Clear? Is that answer your question?
Yeah, but the trust store, we create the trust store, yeah?
No, in IAB, no need to create the trust store. Don't do that. It is already there.
Oh, it is already there?
Yes, that is CSX only. CSX is going to be your trust store.
Okay.
Your trust store name is CSX. It is when we install IAB, it will be default. It will be there. We no need to create a trust store.
Okay.
Okay. Now the thing is, the certificates are that HTTP URLs, that HTTPS URL. We need to place those certificates in this CSX file, and then we are going to invoke our CSX trust store file in our broker path. Then whatever the whatever the flows that cause this HTTP URL by our broker, that will become a successful. So for example, here our intention is we have to make sure our this HTTPS gmail.com URL, we have to make it as a trusted and secured one in our broker. So to do that thing, this URL will be having some valid certificates, right? So these valid certificates, we need to load them in our CSS trust store. That's it. Then whatever the URL call we are going to do for this Gmail URL via this broker, that will become a successful call to the developers. That is what the intention. Now the
hold on.
yeah.
Hold on. So this is CA cert. Is it software based, or I mean, is it like at the IIB software level, or at the broker level?
It's a broker level.
But here, of the IBM MQSI 9002 GR17 LIB security, I don't see any broker here.
No, this is just a path, right? This certificate path, I mean, this trust store is just in this path. That's it. You can put it in some other path, you can use it, you can invoke it in the broker. The only one thing is, in the broker key store path, in the broker trust store path, we have to mention this is CA certificates path where it is physically located. That's it.
Can we move it to another directory?
Yes, we can move it. Why can't? We can easily move it. Simple. Use move command and then use this thing and then use /tmp. Now it will be moved to tmp. Now in the broker, configure this path /tmp/csx.
Yeah,
So
whatever.
that,
Just the system
yes,
is the one we say CA certis. Okay, gotcha.
exactly. All right. So now our main task is we need to get the valid certificates for this HTTPS URL. Now, how to get the URL? I mean, how to get the certificates? So the thing is, there will be for a secure URL, there will be 3 certificates. So the first thing is a root certificate for that URL. Second thing is intermediate certificate. Third thing is public certificate. So these 3 things we have to get that URL, and these 3 certificates we need to import into our CS search file. So root certificate is something. This is a signed version of the certificate, and this will be signed by some third-party companies like Verijon, Tharte, and around 20 to 30 CA companies are there in the world. So when we request them, they will, and when we pay them, they will give us a root certificate for our URL. We just have to share that URL to the company so that they will create a root certificate for that. So the companies pay the money to the certificate companies for providing this root certificate only, because it's a signed certificate. So the second thing is intermediate. Okay. So first of all, let's concentrate about the public certificate. So a public certificate is something. This is going to be a public certificate of the URL. I mean, of the HTTPS URL. So public certificate in the sense, anyone can invoke it. For example, if I invoke it, I can call that the HTTPS URL. I mean, I can do a proper handshake. For example, see, you have a valid certificate. You are the authorized person for that, and you have given me the associated public certificate. Now I can do a proper handshake with you. I can connect with you. Now the same public certificate, if you are given to some other person, that other person also can be connect with you. He can do a proper handshake with you. That's what the public certificate is. It means from any browser, you can call your HTTPS URL if you have the public certificate. That's what the public certificate is. And the intermediate certificate is, it is going to place in between your root certificate certificate and your public certificate. It is like a connection certificate between root and public. This is going to validate your root and public are same or not. It's like an intermediate certificate between root and public. So that is what this intermediate certificate is. So now for that Gmail URL, we have to download root certificate, we have to download intermediate certificate, we have to download public certificate, and then we have to import all these three certificates in our CES of that particular broker, so that from that broker we can successfully call our HTTPS URL. So for example,
so for one certificate, we have to have these three things must always?
it's must. It's always must.
Let me see the list. I mean, the root certificate, intermediate certificate, and the public certificate.
Yeah, here is the list.
How we produce them, like how we make a certificate.
That is what I am going to show you now. Okay. I mean, so we need not to make the certificates. Certificates are already there in the URL. So here is the URL, right?
Yeah.
So
yeah,
when the
this one was already certificate.
right. So when the URLs are developed, these are developed by the developers. I mean, the certificates will be already invoked by the developers. Now the thing is, we have to download these certificates. Our developers has to share the certificates. Say these are my license certificates. Can you please invoke them in the broker? That is what the duty of IIB admin. Now the developers can share us the direct certificates, or they can share us the URL. For example, they have shared the URL. Hey, please download the certificates from this URL. Now I have placed that URL in my browser. When I placed it, do you see a lock symbol here?
Yeah.
Click this. This is the place where our certificates will be invoked for that particular URL via browser. So there is an option called certificate. See, this certificate is issued by some GTS CA 101. So this is a CA vendor. So Google must have paid something to that GPS company so that they created all these certificates. So when I click that, come on, what happened? Okay, hold on 1 second. Let me delete these things. Okay, so when we click this lock symbol, there will be something called certificate. When we click the certificate, it will open like this. So there are three types: general, details, and then certificate path. So when you go to certificate path, it is going to show three things: Google Trust Services, Global Sign. So this is the root certificate. You can see Global Sign root CA. So it's a Google Trust Services is the company where these certificates are provided. It means Google must have their own CA, and with their own CA they build it. And then GTS CA 101. This is going to be an intermediate certificate, and then star.google.com. This is going to be a public certificate. So we need to download all these certificates. First of all, I'm downloading the root certificate.
Hold on.
Yeah.
The second one, the one you mentioned as intermediate certificate, GTS CA 101. I think from this thing, what I could see is like it says Google Trust Services, Global Sign Root CA R2. I think this one is the original. I mean, like in hierarchy, that is the company which Google have an agreement with, and this company then outsourced some small company out there it trusts to sign this certificate and deliver it to the Google. So the one you mentioned, intermediate certificate by itself, is actually not the certificate. The intermediate is the just the company which is right here. It is like it is like you have a certificate signing company, and your company is bigger and well known. So markets come to you, like hundreds and thousands of people just want to get a certificate signing from you. Being not able to handle all those certificates, you start giving out under your ownership to small companies which does the same thing. So Google trust you, you trust this GTS, then GTS produce a ticket and deliver it to the Google. I think that is what it looks here, rather than like the certificate. The intermediate by itself is a certificate.
So tell me one thing, what do you think GTS means? You think it's a different company?
That is how I got it.
No, it's GTS means it's a global trust services only. It's
What is
their
that?
own company.
Global what?
No, it's Google Trust Services.
Or Google Trust Services?
Yes.
Okay. So
So
you're
this
telling
here,
me
here,
you
here the thing is Google have their own CA. Google itself generates the certificates.
okay.
So when Google have a capability of generating their own valid certificates, why they would go to why they need to depend on different CA? Not required, right?
Yeah.
So here everything is developed by Google itself because Google has the capability of developing the certificate, the valid certificates, and that is called Google Trust Store. Sorry, it's that's called Google Trust Services. So the first thing, Google Trust Services, it's a root CA developed by Google Trust Services company, and GTS, it is an intermediate certificate that is also developed by Google Trust Services, and the public certificate that is also developed by Google only. But this is for Google. I mean, how would I say? From different departments. So Google.com is a different department. Google Trust Service is a different company. I mean,
Just
parent company,
within the
parent,
company, within
yes,
the company, some
parent
other
company is
branch.
same. Exactly. Parent company is same, but different branches. Exactly.
Yeah. So you're telling me for to produce one certificate, they have to make three things at once.
Yes, exactly. They have to provide three things.
So what is that Google Trust certificate? The one we call it root certificate. What that root certificate
Okay.
is in
So
terms of?
this root certificate is going to sign your intermediate certificate and your public certificate. So, okay, let me tell you one thing. For example, when we have written an exam, whether it's an academic exam, whether it is a competitive exam, how you are going to get the certificate? Someone has to validate, someone has to given you pass marks, then only you are going to get a valid certificate. Yeah, you have cleared this exam, right? Now this thing is you have your public certificate, you have your intermediate certificate. Now who is going to validate it? Someone has to validate, someone has to give you that certificate that yes, this is a valid certificate. Someone has to sign that, someone has to trust it, right? The
Yes.
validation part is going to done by this company, Google Trust Services. So this is called a root. So root is something that root is going to sign your certificates, that is going to validate your certificates. That is what root is.
Or the other produces and the root science is.
Yes, right. Root sciences. Root signs it. Clear? Is that answer your question?
So we have to upload like three of them at once.
Exactly. we need to upload root also, we need to upload intermediate also, we need to upload this public also, public certificate also.
Okay, where is the private key thing place here?
Private key thing will be in the intermediate certificate.
Okay. Okay, thank you.
Yeah, no problem. So now I'm downloading it. So to download it, I'm downloading the root certificate now. To download it, click on the root certificate, click on view certificates, and click on details. There is some option called copy to file. Click on next. Yeah, select the DER. This is the best recommended one. .CER format. Click on next. It will ask for the file name. So what I'm choosing is I'm choosing my desktop, and the file name I'm giving like G root. It means Google root certificate. Save. Next. Finish. Now the export was successful. Now if I go to my desktop, now I can see something called groot.sir. It means it's a Google root certificate which we downloaded just now. Now the second thing is we need to download the intermediate certificate. So click on the intermediate certificate, click on view certificate, go to details, click on copy to file, next. So select DR encoded .CER format, next, and the file name. So click for browse, click on desktop. I'm giving the name something like G Inter. It means Google Intermediate Certificate. Save, next, finish. The export was successful. Now if I go to my desktop now, see, I can see one more certificate called G-Inter.sar. It means it's a Google Intermediate Certificate. Now, finally, we need to download the public certificate. So select this. Yeah, select this. Go to details here. So go to details here. You're saying something?
Okay, go ahead.
Okay. So click on copy to file. Next, next, browse, desktop. I'm giving something like GPUB. It means Google Public Certificate. Save, next, finish. The export was successful. Okay. Now I can see public certificate also. Now we have all the needed certificates. We have the root certificate, we have the intermediate certificate, we have the public certificate. Now our duty is we need to import all these certificates into our CEA certs, which is our trust store file. That would be enough. So first of all, import all the, get all these certificates to in our Unix server, in our Linux server. So for that, I am using something called WinSCP tool. So what's my IP address? I config. Yeah, login as a root and my root password. What? Access denied? Don't. Oh, the username is root. Okay, got it. Got it. My username itself wrong. Yeah, now it's connected. So my certificates are in the desktop. So go to desktop. See, I can see all my certificates. So let's put them in some temporary location, TMP. Select all my certificates, do a drag and drop. That's it. I got the certificates. Now go to /tmp ls-lrt. Here are the certificates we can see. Now the thing is, it is having some root permissions, right? So don't have, okay, that's okay to have the root permissions. But instead, let's change the root permissions and then let's change the ownership also. So switch to root user, /tmp. So chmod, no, chown, MQM, MQBRKRS. Okay, so G star. So that all my file names which start with the G are going to have MQM, MQBRKRS 755 permission. TH mode 755 G star plus minus LRT. Yes, now it's done. Now switch back to MQM, go to /10. Now I can see all my files here. Now if I open groot.ser, I mean cat is a command to see the content of a file in the Linux. Click enter. So a root certificate, definitely we can see it is going to see something like global CA root, something like this. Some data will be like this. If you don't see the data of the root, that's okay. Don't worry about it. Now if I do cat enter certificate, again that is going to look like this. That's okay. If I cat public certificate, that is going to look like this. See some data, some google.com, google.com, google.com. See some data is there. Okay, now import all these three certificates into our CA sets. So our CA sets.
Yeah, before you importing it, why we needed to change the read-write access there, because we are not going to write anything into this certificate.
We are not going to write it to anywhere, but you know we did a WinSCP via root user, right?
Yeah.
So the thing is, when we are importing the certificates into CA sets as an MKM user, sometimes it may throw an error or it may not functional. That's why we need. It is always recommended that change the ownership and then also change the permissions as well. It's a recommended thing.
Okay. So you made 567. I mean 67. Say 765.
No. I have given 755 permission.
Oh, 755.
Yeah.
Okay.
Now the next part is we need to download all our certificates into our store, which is CSS. So our CSS file is in OPT, IBM, MQSI 9.0, then where it is, then LIB, no, not LIB, JRE 17, JRE 17. It's a difficult to remember, but that's okay. I know where it is. In LIB, there is something called security.
But still we can move. Still we can move the place and make it like short, yeah.
Yeah, we can make it short, but that's okay. Keep it like this. I will tell you why we put this long part. You will get to know when we're configuring at the broker level.
Okay.
Okay. So right now the CA search is having some data, right? So remember one thing, when we are importing any certificates into CA sets, so it is having some data, maybe some valid certificates could be there. So always take a copy of CA sets. Always have a backup of that. BKP. The reason is, if something gone wrong with this, we can immediately reload with our existing backup file. It's always a recommended thing. Do not forget about it. Okay.
Okay. So you created another new file?
Exactly. I just did a copy, that's it.
Yeah.
Okay. So it is already having some certificates. So to list out the certificates, the command is going to be Tool minus list. Okay. So there is a command called key tool. So it is always done when we install IIB. This key tool will be also configured. So no need to create a separate fashion. So key tool. Okay. Let me recollect the data. Key tool minus list. Yeah. Key tool minus list minus key store. What's our store name? CSS. And when we do this, okay, hold on. So when we do this, the CA processor always will be having a password, and the password is going to be changed. So CSX default password is going to be changed. So remember one thing. So we need to configure anything when we install broker. Broker is going to set this password for this CSX.